Good morning, children. I am Nagamani, JL Chemistry, Naidpeta. Today we are going to learn about 18th group elements, chemical properties of 18th group elements. Chemical properties of 18th group elements. What are the main chemical properties? Generally, we know that these 18th group elements, or it is also called as the zero group elements or the noble gases. What are those noble gases? Those are helium, neon, argon, krypton, xenon, and then radon. So these are the main important 18th group elements. Here we will write the electronic configurations. It is 1s2, neon it is 2s2, 2p6, argon it is 3s2, 3p6, krypton it is 3d10, 4s2, 4p6, xenon it is 4d10, 5s2, 5p6, and radon it is 5d10, 4f14, 6s2, and 6p6. So these are the electronic configurations of these 18th group elements. We have already learned about it. So we will go the same similarity here, that is all other elements except helium. All other 18th group elements are having the outermost electronic configuration, that is ns2 np6. ns2 np6, that means they are all having the octet configuration. Due to the presence of octet configuration in the valence shell, so they will show the reluctant towards the chemical reactions. So these are the inert, so they are called as the inert gas elements. Why they are showing reluctance? That means they are already completed their octet configuration, that is ns2 np6 in the valence shell, so they are reluctant to participate in the chemical bondings. So we can conclude that these noble gases or the 18th group elements are reluctant to participate in chemical reactions, so they are called as the noble gases. So that is about the chemical inertness. Why they are chemically inert? Why they are chemically inert? There are two reasons for this inertness of the chemicals. That is, first one is already we have known the octet configuration, that is the main reason. And second one is the highest ionization energy. Highest ionization energy. Why they are having highest ionization energy? In this according to this electronic configuration, they have completely filled orbitals. When we remove one electron from it, it is very difficult to remove an electron from the outermost orbit. So they will show the highest ionization potential, and then highest electron gain enthalpy also. Highest electron gain enthalpy. So due to these reasons, all these noble gases are inert to participate in the chemical reactions. And next one is what is the first compound which is identified by the Bartlett? The first compound which is identified by the Bartlett is oxy platinum hexafluoride, O2 plus and PTF6 minus. It is a complex. It is a complex. So oxygen is the cation, whereas platinum hexafluoride, it is the anionic complex. So Bartlett identified this compound. So he also identified by the many discoveries, that means oxygen, the ionization potential of oxygen, that is 1157 kilojoules per mole. It is equal to the ionization potential of xenon, that is 1150 kilojoules per mole. So xenon and oxygen is having the same ionization potential value. And next one is the helium, neon and argon, they do not participate in the chemical reactions. That means they do not give any compounds with the another elements, whereas krypton and xenon, they will participate in the chemical reactions. Krypton and xenon are the participate in the chemical reactions. So what are the krypton and xenon? So xenon compounds are very familiar, whereas the krypton compounds are very less and very fewer. So here Bartlett prepared a compound of xenon in the laboratory. What is that compound? It is xenon hexafluoroplatinate. It is xenon is the cation, whereas platinum fluoride, hexafluoride is the anion. So it is the first compound which is prepared by the Bartlett in the laboratory. That is the first compound of the xenon compounds. So what are the main compounds of xenon? Xenon combines with fluorine and oxygen. Why xenon combines only with the fluorine and oxygen? Because these two are having the highest electronegativity. So xenon will combine easily with the fluorine and oxygen. What are the main compounds when xenon combines with the fluorine and then oxygen? When xenon combines with the fluorine, it gives 3 types of halides, that is 3 types of fluorides, that is xenon difluoride, xenon tetrafluoride and then xenon hexafluoride. So these are the main compounds which are formed by the xenon and fluorine. When xenon combines with oxygen, it gives xenon trioxide. Xenon and oxygen compounds are xenon trioxide and xenon tetroxide. So these are the main important compounds, and another compounds are also there. They are XeO2F2, xenon dioxidifluoride, and xenon XeOF4, xenon oxytetrafluoride. These two are also important compounds. Why xenon fluorides are prepared? That means they are the best fluorinating agents. These xenon fluorides are the best fluorinating agents. So they are prepared rigorously. Next one is the preparation of xenon fluorides. Preparation of the xenon fluorides. How we can prepare xenon fluorides? We can prepare, first of all, we will discuss the xenon difluoride. That is the simplest fluoride of the xenon difluoride. How we can prepare xenon difluoride? Xenon difluoride can be prepared. Excess of xenon reacted with the fluorine at 673 Kelvin temperature and 1 bar pressure. 673 Kelvin temperature and 1 bar pressure, it gives xenon difluoride. When xenon and then fluorine are reacted in the 1:5 ratio, when they reacted in the 1:5 ratio at 873 Kelvin temperature and 7 bar pressure. 873 Kelvin temperature and then 7 bar pressure, it will give xenon tetrafluoride. And next one, when xenon reacts with fluorine in the ratio of 1:20 at 573 Kelvin temperature and 60 to 70 bar pressure, we will get xenon hexafluoride. So these are the main preparation methods of the xenon fluorides. Xenon difluoride, xenon tetrafluoride and then xenon hexafluoride. Here we can observe a simple thing, that is when xenon fluorides are prepared, they are prepared directly from the elemental combination at different reaction conditions at 673 1 bar pressure, 873 7 bar pressure, and 573 at 60 to 70 bar pressure. So at different conditions, at different reaction conditions and reaction mediums, we will get the different fluorides of the xenon. So these are the main preparations of the xenon fluorides. And next one is the structures of xenon fluorides. Structures of the xenon fluorides. What are the first one is XeF2. In this XeF2, xenon is the central atom. Xenon is the central atom. It undergoes sp3d hybridization. So sp3d hybridization means generally it has a trigonal bipyramidal structure. It should be trigonal bipyramidal structure according to the sp3d hybridization. Whereas xenon difluoride, it contains 3 lone pairs and 2 bond pairs. 3 lone pairs and the 2 bond pairs. So due to that lone pairs and bond pairs repulsion, it goes to the linear shape. That means we will draw the structure of xenon difluoride. These two are the bond pairs and it has 3 lone pairs. So these 3 lone pairs are in a position of a triangle, whereas these two are in the axial position. So that is about the structure of xenon difluoride. And the next one is the second one, that is xenon tetrafluoride. Structure of xenon tetrafluoride. Here the hybridization of the central atom, that is xenon, is sp3d2. So according to this hybridization, its structure should be octahedral. Whereas we go to the actual structure, it is square planar. The actual structure is square planar. Why it is converted to square planar? Here we will go for the bond pairs and lone pairs. So here no lone pairs are 2 and bond pairs are 4. So due to the repulsion between bond pairs and lone pairs, so its structure will be converted to the octahedral to square planar. So we will draw the structure of xenon hexafluoride. Xenon is the central atom. It has the 4 fluorine atoms are at 4 corners of the square and 2 lone pairs. They are above and below the octahedral plane. So that is the structure of the xenon tetrafluoride. It is the square planar structure. Its structure is square planar. And next one is the xenon hexafluoride, XeF6. So this hybridization is sp3d3. So it is having 1 s orbital, 3 p orbitals and 3 d orbitals. Totally 7 orbitals are present. So according to these 7 orbitals, the structure should be pentagonal bipyramidal. Whereas this structure is converted to So here we will go for the lone pairs and the bond pairs. There is one lone pair and 6 bond pairs. One lone pair and the 6 bond pairs. So due to the presence of the repulsion between the lone pair and the bond pairs, its structure will be go as a distorted octahedral. Structure will be converted to distorted octahedral. So we will draw the structure of xenon hexafluoride XeF6. So here it is a one lone pair. So this is this, sorry. So this is the structure of the distorted octahedral of xenon hexafluoride. So these are the structures and hybridizations of the xenon fluorides. And the next one is the, we have already known that the all xenon fluorides are best fluorinating agents. So when they easily react with the water, so all these xenon fluorides, that is XeF2, XeF4 and then XeF6, all these are in solids. They are all the solids and they are easily sublime. That means they will readily goes into the vapor state and easily convert into the solid state. That is called as the sublime quality. So that is about the physical properties of the xenon fluorides. And next one, they will react with the xenon fluorides will easily react with the water. Even traces of water also, they will readily give the products with the water. First of all, we will go for the XeF2. XeF2 plus H2O gives rise to 2Xe plus 4HF. It is a gas. Xenon is also gas and oxygen too, that is also gas. So xenon difluoride will give xenon gas, HF gas and then oxygen gas. That is about the reaction with water of the xenon fluoride. And the next one is the xenon. This is called as the hydrolysis. Any compound with reaction with water, it is called as the hydrolysis. So xenon difluoride and hydrolysis, it gives xenon gas, hydrogen fluoride gas and then oxygen gas. And next one, second one, that is xenon tetrafluoride, that is XeF4. XeF4 on reaction with water, H2O, gives rise to Xe xenon plus XeO3. We have already known what is it. It is the xenon trioxide and then hydrogen fluoride HF and oxygen. So here we will balance the equation that with 6H XeF4 plus 12H2O, whereas 4Xe and XeO3 24HF and then 3O2. That is the equation. So XeF4 plus H2O gives rise to Xe plus XeO3 plus O2, HF plus O2. So these are the main products which are gives from xenon hydrofluoride on xenon tetrafluoride on the hydrolysis. So next one is the, so here we will have the new compound, that is XeO3. This is the new compound here. And next we will go for the next reaction, that is XeF6. XeF6. XeF6 on hydrolysis with water, it will give XeO3 and then HF, hydrogen fluoride. XeF6 plus 3H2O gives rise to XeO3 plus 6HF. So that is the main chemical reaction involved here. So we will conclude that on the hydrolysis of XeF4 and XeF6 gives XeO3. Both will give the XeO3. Whereas on partial hydrolysis of XeF6, it will give the XeOF4 and XeO2F2. XeOF4 and then XeO2F2. So these are the important compounds which are given by the xenon hexafluoride on the partial hydrolysis. So we will go to the structures of XeO3, XeOF4 and XeO2F2. Next one is the structure of XeO3. In this central atom is xenon. It undergoes sp3 hybridization. So there is a p pi and d pi bonds in between the xenon and oxygen atoms. There are 3 p pi and d pi bonds are present in between the xenon and then oxygen atoms. So it undergoes only the sp3 hybridization only. Undergoes the sp3 hybridization. So according to this sp3 hybridization, xenon has the 4 pairs, that is it should be in a tetrahedral structure. Due to the presence of one lone pair and 3 bond pairs, there is a repulsion between the lone pair and bond pairs. Its structure is converted to pyramidal. So we will write the structure of xenon trioxide. 3 oxygens are having the d pi p pi bonds and one lone pair which is present at the top of the xenon atom. So its structure will be pyramidal. That is about the structure of XeO3. And the next one is the XeOF4. Structure of XeOF4. So the structure of XeOF4, its hybridization is sp3d2. That means 1 s orbital, 3 p orbitals and 2 d orbitals. That is totally 6 orbitals are present. When 6 orbitals are present, the structure will be octahedral. Structure should be octahedral. But the presence of one lone pair on the XeF4, that means one lone pair and 5 bond pairs. One lone pair and the 5 bond pairs. Due to the presence of lone pair, there is a repulsion. So due to that repulsion, the structure will be deviated from octahedral to square planar, square pyramidal. Octahedral to square pyramidal. Structure is converted from octahedral to square pyramidal. So now we will write the structure of XeOF4. That is, there is one lone pair, one oxygen. Oxygen is double bonded and 4 fluorine atoms are 4 corners of the tetrahedral or the octahedral. 4 corners of the octahedral. So this is about the structure of XeOF4. It is in the octahedral. It should be in the octahedral shape as per the hybridization, but due to the presence of one lone pair, its structure will be converted to square pyramidal. And next one is the XeO2F2. xenon dioxydifluoride, XeO2F2, xenon dioxydifluoride. Its hybridization is sp3d. So it is having the 5 orbitals. It is having the 5 orbitals. So that means it is having 3 bond pairs and 2 lone pairs. 3 bond pairs and 2 lone pairs. Due to the presence of 2 lone pairs, its structure will be, as per the hybridization, its structure is trigonal bipyramidal. Trigonal bipyramidal, but it is converted to the seesaw structure. Is converted to seesaw structure. Now we will draw the structure of XeO2F2. Xe double bond O, XeF, F. Here it is a lone pair, and here it is one double bond O and another double bond O. So that is the structure of it. Is also the structure is called as the seesaw structure. So that is the structure of the XeO2F2, xenon dioxydifluoride. So another xenon oxide, that is XeO4, that is xenon tetroxide. It is also, the central atom is xenon. It undergoes sp3 hybridization. Here there are 4 d pi p pi bonds in between the xenon and oxygen atoms. So its structure should be tetrahedral. Structure is tetrahedral. Central atom is xenon and it contains 4 double bonds of 4 oxygen atoms. So its structure is tetrahedral. So these are the main compounds of xenon with relevant structures. And next one is the reactions of xenon with other compounds. That means they will donate one fluorine to give a fluoride ion or fluoride complexes. So what are those fluoride complexes? First of all, then we will go for the another reactions. Xenon fluoride reacts with fluoride ion acceptors to form cationic species, and with fluoride ions donors to form fluorine ions. So first of all, we will go to the XeF2 plus fluoride ion acceptors. What are the fluoride ion acceptors? That is PF5, 15th group fluorides. 15th ante phosphorus, arsenic, antimony, and then 15th group fluorides will accept the fluorine atom from the xenon fluorides to give fluoride anion. That is XeF. It is the XeF, it is a positive ionic complex, and PF6 minus. So that is one complex ion. And next one is the XeF4 plus another 15th group fluoride, that is antimony fluoride SbF5, gives rise to XeF3 plus SbF6 minus. And next one is the XeF6 plus another fluoride, that is metal fluoride MF. M means here the M is the here the M is equal to Na, K, sodium, potassium, rubidium or cesium. That means first group elements. M is the first group element because it is highly electropositive. So XeF4 plus MF gives rise to M plus XeF7 minus. Only these first group elements will give the heptafluoroanion. Heptafluoroanion. So these are about the reactions of the xenon fluorides with other fluorine accepting molecules. So that is about the xenon chemical properties of the chemical properties of 18th group elements. Most important ones are the fluorides of xenon, that is XeF2, XeF4, and then XeF6 preparations and structures, XeOF4, XeO2, F2 preparations and structures. These are the important and then XeO3 structure. So these are very important for the both 4 marks questions as well as the 8 marks questions. So now we will go for the next chapter. If you have any doubts, please call to your teacher.